Let A be this 3 cross 3 matrix, B be another matrix, A minus I, where I is 3 cross 3 identity matrix. Omega is complex cube root of unity, minus 1 plus root 3 iota by 2. Then we have to find the number of elements in this set n. N is first 100 natural number such that A raised to n plus omega B raised to n, this is A plus B. So first basically we need to identify the type of matrix that we have here, right? A is a given matrix. So first let us try to find which type of matrix is this matrix A. Then B is A minus I. Omega is complex cube root of unity. So first, in order to identify the type of matrix, let us calculate A square, right? If we calculate A square, if we get A square as identity matrix, that means matrix is involuntary matrix. If I get A square as matrix A, then it means matrix is idempotent matrix. So first let us calculate A square so that we can get some idea that how to proceed in this problem. So for calculating A square, we have to multiply matrix A with A. So here we have 2 minus 1 minus 1, then we have 1 0 minus 1, and then we have 1 minus 1 0. This is matrix A, and A square means matrix A into matrix A. So we have to multiply the matrix with itself, right? So again, I'll repeat the same matrix. We have 2, then minus 1 minus 1, 1 0 minus 1, and then 1 minus 1 0. Now, if you multiply these two matrices, you can do the multiplication on your own. When you multiply these two matrices, you will get the same matrix A, right? If you multiply first row, first column, then we are getting 2 minus 1, 4 minus 1 minus 1, so that is 2. So you will get this element. First row, second column, that will give you minus 1 and so on. So this multiplication you can do on your own. Once you calculate A square, you will find that A square, this is same as matrix A. And if A square is matrix A, that means the given matrix is idempotent matrix, right? In case of idempotent matrix, A square is matrix A. And if A square is matrix A, then any power of this matrix, right, A raised to n, this will be always A. This is one property of idempotent matrix, that if A square is A, then A raised to n, this is also A. Because, I mean, you can very easily see this one, that if A square is A, if I have to calculate A cube will be A into A square, and A square is A, so this will again become A square, and A square was same as matrix A. So in similar manner, you can show that any power of this matrix A, that will be matrix A only, right? So now this equation, A raised to n plus omega B raised to n, and on right hand side, this is A plus B. So if matrix A is idempotent matrix, then A raised to n, this is nothing but matrix A. So basically we have omega B raised to n, and this is A plus B. Matrix A you can cancel from both sides. So then finally we have this relation, that omega raised to n into B raised to n, this should be matrix B. So this is the relation that we have to satisfy, because matrix A was idempotent. So A raised to n, that is matrix A only. So now the equation that we have is omega raised to n into B raised to n, and this must be matrix B. So for that, matrix B is given. Matrix B is A minus I. So now let us try to calculate different powers of B. Also from this one equation, you can write two equations. One is that omega raised to n, this must be 1, and B raised to n, this must be B, right? Because omega is complex cube root of unity. So if I equate the coefficient of this matrix, omega raised to n must be 1. So if omega raised to n, this is 1, this will imply that n must be multiple of 3, right? Omega cube is 1. So omega raised to 3 or omega raised to 6, all of those numbers will be 1 only. And n is set of first 100 natural numbers. So that means n will be either 3 or 6 or 9 or 12. N will be multiple of 3 only, right? Remember, we need to satisfy both of these conditions. So first condition will be satisfied if n is multiple of 3. And now we have to focus on the second one, that how we can make B raised to n as B. So for that, it is given that matrix B is A minus I, right? This result is given, that matrix B This is matrix A minus I. So let us calculate B square first, right? If this is matrix B, B square will be A minus I square. And because A and I, these two are commutative matrix, so therefore here we can use A plus B whole square formula, because I into A, that will be same as A into I. So this will become A square plus I square and then minus 2I. Now because A square is same as A, since matrix A was idempotent matrix, so this we can write as I, and then A minus 2A, that will be minus A. Now remember, matrix B was A minus I, and B square we are getting I minus A. So this will mean that B square, this is nothing but negative of matrix B, right? B square is uh, I minus A, and matrix B, this was A minus I. So this means B square, this is minus B. Now, how to use this relation? So if B square is minus B, just multiply again by matrix B, and then we have B cube equals to minus B square. And what is minus B square? Minus B square, this is same as matrix B. So that means B raised to 3, this will be matrix B. Now, this is another important relation, that if BQ is matrix B will be periodic matrix, right? In case of periodic matrix, A raised to n plus 1 is same as matrix n. So if B cube, this is matrix B, this will imply that matrix B is periodic matrix. And what is the period of this matrix? So period will be nothing but 2, right? I mean, for periodic matrix, the definition is A raised to n plus 1 is matrix A. Then we have a periodic matrix, n is period. So here this 3 you can write as 2 plus 1. So that means we have a periodic matrix with period 2. And that will imply that matrix B, this is same as B cube. This will be same as B raised to 5, right? Just keep on adding 2 in this and you will get the same matrix. And again, it is not difficult to show this result, right? If I have to show that B raised to 5 is same as B. So B raised to 5, this you can write as B cube into B square, right? B raised to 5 will be B cube into B square. And what is B cube? B cube is matrix B. So this becomes B cube. And this was same as matrix B, right? Using this result, once we have the relation that B cube is same as matrix B, we have a periodic matrix with period 2, and just keep on adding 2 in exponent, we'll get the same matrix. So B raised to 3, 5 or 7 or B raised to 9, all of these matrices will be same, right, up to B raised to 99. So if I have to satisfy this second condition that B raised to n, this should be same as matrix B. So then it will imply that n must be any one of these number. N has to be either 1 or 3 or 5 or 7 or 9 up to 99. Right, now let us call this 1. If omega raised to n is 1, then n must be multiple of 3. And if b raised to n, this is same as matrix B, then n must be all of these odd natural numbers. So now, because we have to satisfy both the conditions, we need to take intersection of 1 and 2. So if I take intersection of 1 and 2, then n will be this set, right? N will be the common values 3, 6, 9, 12 and so on, 1, 3, 5, 7 and so on. So the common values are 3, then next number will be 9, right? After that 15, then we have 21 and so on, right? We'll get multiples of 6 plus 3. So the last common term, this will be 99. And now we need to find how many common terms are there. I mean, how many terms are there in this set, right? So clearly you can see that in this set, the total number of terms will be when you can calculate this one, you can using the formula of AP, or directly also you can see this result, that if I remove 3 and then divide everything by 6, then we'll get 96 by 6, that is 16 plus 1 more term. So total number of term in this series is 17. So that will be the correct answer for this problem. So I'll quickly summarize what we have done in this question. First, we have calculated A square. A square was same as matrix A. That means we have idempotent matrix. In case of idempotent matrix, any power of that matrix is matrix A only. So if A square is A raised to n will be A. And therefore, these two terms, they will cancel. So basically, we had to satisfy the condition that omega raised to n into b raised to n. This must be matrix B. right? So from here we have two conditions. One condition omega raised to n is 1 and second condition b raised to n is b. Now omega raised to n is 1, that means omega n must be multiple of 3. So from there we got these values of n. Remember, we need to satisfy both of these conditions, and therefore finally we had to take intersection. So this was if I take n as multiple of 3, then we can satisfy the first condition, that omega raised to n will be 1. And B cube, this was matrix B, which means we have a periodic matrix with period 2. And then if B cube is B raised to 5, 7, 9 and so on, all of them, that will be matrix B only. So if I have to satisfy the second condition, that B raised to n, this is matrix B, then n must be odd natural numbers, 1, 3, 5, 7 and so on. And because we have to satisfy both the conditions, we need to take intersection of those two. So this was the intersection of first and second set of values of n. And now in this set, total number of elements is 17. And therefore, the correct answer for this problem is 17.